Thank you very much. I appreciate Matt's talk this morning about naming a project being very important. Hopefully you like ours. We're going to start off with some introductions about ourselves. I'm Paul Tarjan. I've been at Stripe for 2.5 years, the entire time working on the developer productivity team. Before that, I was at Facebook for 5 years, working on all sorts of different stuff, most notably HHVM and Hack the Language.
Hello everybody, I'm Dmitry. Before joining Dev Productivity at Stripe, I worked on Scala compiler, and the next major version of Scala compiler, Scala 3.0, will be based on my design.
I'm Nelson. I've been an engineer at Stripe for 5 years, working on systems infrastructure and then more recently developer productivity. Prior to that, I worked on hot patching the Linux kernel at a startup called Ksplice.
All right, thank you, friends. Hopefully you enjoy our talk. Number one, what is Stripe? Some of you have not heard of us. Hopefully many of you have. We are a platform that developers use to accept payments. We are in 25 different countries. 100,000 businesses worldwide use us. Interesting fact, about 60% of people in the United States have used us in the last year for a transaction. And I do suggest, if you are running an internet business, please do check out Stripe. It will be an enjoyable experience if I can have my way. We do have a Tokyo office, so something nearby if you're interested. There is many of the folks from the Tokyo office in the audience. Can we wave? Chat to these fine folks if you are interested in anything Stripe Tokyo. And the obligatory link that you have to put on any conference slide if you're from a company, stripes.com/jobs. So we did talk that we are under a umbrella team called Developer Productivity. Our company is very dedicated to this. We believe very strongly that the effort of putting effort into developer productivity gets a lot of rewards back at the end. Our team has many sub-teams within it. We focus on all parts of the pipeline from the moment the code needs to be, while the Git branch is created, all the way until your code is deployed. We specifically are on the language tools side of this. Our job is to make Ruby better, at least at Stripe. Hopefully better for you. OK, giving some background about how we use Ruby. We are a very large Ruby shop. We have millions and millions of lines of code, all written in Ruby. It is our primary programming language that we use for developing our product, as well as many of our internal tools. We do not use Rails. Okay? So this is actually an important distinction that you will see later on in our type checker. We do, though, have an enforced subset of Ruby. So thank you, B. Bastov, for RuboCop. We appreciate it highly. Hopefully we've contributed back a bunch to your project that you enjoy. And we have over 300 rules internally for holding the line, both syntactic and semantic. Most of our code is in a monorepo. This is intentional. This isn't a fact of history, an accident of history. We are a macro service architecture. So we have very large services that have many functionality inside the same thing, and a few satellite microservices around their sides. And lastly, new code is not being rewritten. We aren't in the process of switching to microservices or that kind of thing. We do embrace this architecture, and we are deploying all new code into most of the macro services. Okay, that is the shape of Ruby at Stripe. Here's our programming language breakdown. Give you an idea of what we're using. It is our #1 language. Almost every engineer is trained in Ruby when they join the company. Our second most popular language is our front-end language, JavaScript. Our third most popular language is YAML. Very excellent language. I do love YAML. And then a smattering of other languages for various services and niche components. We have millions of lines of code, hundreds of engineers, and growing quickly, and thousands of commits a day. Our code team has their hand full with running our Git repository. OK, we are not the first type checker for Ruby. We are standing on the shoulder of very tall giants, so we appreciate all the work that has come before us and will collaborate with us, hopefully. Diamondback Ruby, pRuby, Ruby Dust, RTC, and RDL are 9 years of names that Jeff Foster and his team at University of Maryland has been working on. Excellent project, we appreciate them, and have used a lot of their runtime annotations for the standard library, even in our type checker. There's an unreleased GitHub experiment by a friend of ours, Charlie Somerville at GitHub, who has gracefully lent us some other code for our parser. There is 2 presentations tomorrow, mentioned by Mats earlier at the keynote, and we shall mention as well. Please go talk to our friends. And lastly, there's a contracts that was chatted, I think, last year at RubyKaigi about contracts by JetBrains. So lots of interest in the space. We appreciate it, and we are happy to use what has come before. Okay, the elephant in the room. Are we open source? Eventually, we will open source our project. The goal is not for us to build something in isolation just for ourselves. Our goal is to help the community and build out a type checker. We do have limited resources. We are only 3 people. And the goal is to prove it out internally first, and then once we understand how the type checker works, we will launch it out for the rest of you folks. Although we are announcing today we would like to ask people to write to us if you have any ideas, inspiration, issues. We would just love to hear you. An announcement before a release can help shape the way that the release goes. So please do reach out if you're at all interested in this space or would like to talk about it before then. But I do not like vaporware releases, right? So just talking about something that does not exist is not nearly as fun as showing something that does exist. So if I switch tabs here, you'll see a URL. I before said I worked on the hack language, which is a PHP derivative. And a string plus an integer is a very normal thing for me to do in PHP. I appreciate that that is not possible in Ruby, so thank you. And you'll see that we emit a parser or a type check error at the bottom here. That an expression passed at argument 0 to the method plus does not match the expected type. The string 1 plus the integer 2, that's where the plus operator is defined, and we got the integer 2. So how do we add things? Well, let's call a method. Oh, that's a syntax error. All right, what's the method that we can call on an integer? It's t. No, t is not a valid method. Ah, right. So if I coerce my integer into a string, now I can add it into another string. So here is our type checker running in a browser. As I said, it is not vaporware. Feel free to go to sorbet.run on your device of choice or QR code reader of choice, and feel free to try it out. We will leave it live even after this. And from this point on, no one will listen to the rest of the talk. And with that, let me hand off to my colleague, Dimitri.
Hello, everybody. I'm starting the part which is going to be competing with you trying the editor. So when we started designing a type system, we started designing a type system for Ruby. Ruby is a language which is very different from other languages which already have types. It's very different from Java. It's very different from C++. It's better in many regards. And we wanted to keep the areas where Ruby is better. Thus, we start with some design principles. Because we're a big company and we have a big number of developers, we had to make it explicit. We had to make the type system be written out in source because we wanted to also serve as maintained documentation. At the same time, we wanted to make sure that our developers feel rewarded for the time they've put into writing type signatures. We wanted the type system to be useful, not burdensome. We wanted to be different from Java. We want them to wish to write type signatures and feel that they get something for doing so. At the same time, we care a lot about their user experience even after type signatures were written. We want the type signatures to be understandable. We want type errors to be easy to follow. And thus, while It's easy to build a complex type system which has wonderful features. It's frequently hard to make the errors there look nice. Unhappy paths for complex type systems is quite frequently not the best place to be. The next design principle is, this is Ruby. We didn't modify syntax. We didn't modify parser. We didn't modify anything in Ruby. It runs on bare Ruby. No patches to MRI, no nothing. This is important for us. We use a lot of libraries. We use a lot of IDEs. We benefit from a lot of tools developed by community. And thus, we want to pay it back by staying compatible and synergizing with them. Stripe is already a big company. It will become even bigger. It grows. It grows exponentially. The type checker, the system that we're developing, will have to grow with it. It will have to, currently it's processing dozens of millions lines of code. It will be processing even more soon. We have to make sure that it works with a lot of developers, a lot of commits, a lot of changes, a lot of classes, a lot of methods, a lot of everything you can imagine. It has to scale. And given that the company is so big, and given this is Ruby, we want to allow you to be lax about stuff where you're still experimenting. We want to allow you to sometimes be strict, sometimes be lax. It also helps us with adoption because different teams have different schedules, and they will be can adopt it at different pace. So those are the high-level principles. Let me try to demonstrate them on one of the most important areas which I believe are for type checkers, error messages. Here's a demo of usage. If you use the type system correctly, it stays silent. If you run this line by the type checker, it will just return 0 and stay silent. If you do have an error, like this one, it will try to be very explicit and explain you what you did wrong. Here in particular, if you're trying to add a string and a symbol, it will tell you that you're calling a method plus that takes an argument which doesn't match what you gave it. You gave it a symbol. It comes from here. You have the error. It points to a specific location. And it actually points you to the definition location of the method plus. If you were to have access to our repo and you were to open this link, you'll be able to see the definition. It works very well because it allows you to also jump to implementation if you know better, or if you want to fix the type signature. Being a type system for Ruby and staying in Ruby, we're keeping the common ways to write code in Ruby. For example, if you access an element in an array, in Java, it will return an element. In Ruby, it might return nil if you're accessing an element out of range. Thus, it's very common in Ruby to access something like here in an array, and then you're getting either a string or a nil. We have analysis to figure out whether something can be truthy or falsy, and what does it entail when something is truthy or falsy. Here, if you were to test that foo is not nil, then below this line, we'll know that foo is a string. It's never nil anymore. If you were to forget this test, we'll give you such error, where we say that you're calling empty on a nillable string where a component in it, which is a nil class, doesn't contain a method empty. It's very important for us to keep the error messages short, concise, and useful, all at the same time. There are a lot of other checks that we have which help us find rule bugs. In particular, this is valid code in Ruby. This also showcases there that you can define variables independently. You can declare foo in one branch and another branch, and after the if, anyway foo will be an integer. It's still Ruby. You don't have to pre-declare your variables. It's not Java. It's not C++. But if you're a C person and you're having this common bug where you think that 0 is falsy, you may go into this pitfall. And we'll be able to find this bug for you, where we know that all the floats in Ruby are truthy, so this code is dead. We can also model even more complex types, which you don't have even to spell. Like, this is an array of strings or integers, and when you call method sample on it, you'll get something which is either a string or an integer. Both strings and integer have the method successor, suck, and this code will type check in our system. If you were to add one more element there, which is an array of integers, and try to call the same function, we'll give you an error saying that the suck doesn't exist on arrays, but does exist on all the other components. Here we had a look at how do you use the system. Now let's have a look how do you define the types. This is very important for the library authors of Stripe. Stripe is a big company. A lot of engineers write libraries used by other engineers. They want to make sure that users use those libraries correctly. Sometimes this goes in order to define what's the right usage. Sometimes it goes to define who's responsible for misusage and who's there to blame. So this is how it works. We've defined a DSL, a raw Ruby DSL without any extension, where you write something called sig, which stands for signature, before every method. And here you specify for every argument what's the type of every of the arguments. Here, for example, this is a method that creates a charge. We're a Stripe company. We're Stripe. We're processing transactions. Let's say you were to create a charge of Japanese yen and 100 Japanese yen. You will call this function, and you'll be able to make sure that you pass the arguments in the right order. If you were not to, in particular, if you were to pass them in a different order, there are two things which will stop you from having this bug. One is the static type system that's presenting here, but we also have a previous system that we developed at Stripe to do runtime checking. We can also find if the runtime values are different, and we'll be able to show you the stack trace for where was the bug encountered. So even if the static type checker isn't able to check it, in particular, for example, when you have untyped code somewhere in between, you'll still be safe because the dynamic type system will catch you. As I told, we want to make sure that developers feel rewarded for every type that they write, which means we don't want them to write types that they then don't get rewarded for. For example, if you were to assign a local variable a to 5, we know that's an integer. You don't need to repeat it. You don't need to spend time saying so. If you do want to annotate this for some reason, you want to make sure that it always stays the same time, you can declare it. We have something called t.let, which allows you to specify the type that you were expecting. We also allow you to reassign the variables with different types. This is valid code. A is a 5 in this line, and now it's a string. You can change the type. That's fine. We'll handle it. As I told, we want to allow you to adopt the system at different pace, and we want to allow you to experiment in the areas where you want to, and at the same time while allowing you to be strict if you want to be strict. That's why we have several strictness levels. If you don't define a strictness level, you get some basic errors. You'll get parse errors very early. If you mistype some constants, like you have a typo in the word integer or float, you'll get errors. Next level will be types true. And this level will do actual type checking. We'll use the types which are available from around the code base and try to find whether you're misusing something. The next level will be type strict. Type strict is a step where you want to stabilize the code. Type strict requires you to declare all your types for ivars. This is more or less the basic difference, but it allows us to catch a lot of bugs. At a small cost for you, declaring types of local variables, or types of ivars. And the strongest type is typed strong. At this level, for this file, we'll require to type check everything. There's only a small number of files who decided to go into this route. This is very strict. This means that you're writing some very critical code which has to run right. It's very uncommon to be at this level. But if you want, you can be there. When we're discussing the type system, we said that it has to be simple. But it has to be expressive. It means that we have some both basic and advanced features. Some of the basic features include generics. Generics are necessary to model stuff like arrays, sets, maps, various containers, where the declaration side doesn't know everything about type signatures yet. For example, the box, which can contain any element, and it doesn't know at declaration side what would it contain when it's instantiated. The use side here will say that it's actually an integer box. Yep. Probably the most complex part of our type system is generic methods. It's necessary to model stuff like array.map, where you don't want to spell times. At the same time, you want them to be quite precise, and they depend on arguments that you're passing. The syntax is kind of verbose, but it works well and is able to model methods in the Ruby standard library. Thank you for following up with me with examples of errors on the declaration side. Now we'll transition to Nelson, who will talk about our experience of deploying this system and feedback from the users that we got who used it.
So the title of our talk was a practical Ruby type system, static type system for Ruby. And I think one of the things that's really fun about our type system is we've been developing it, and we really get the chance to roll it out to users as we develop and see how it works at scale in a large code base. So I want to talk through a little bit of what our experience has been bringing this to users at Stripe and where we are in that process. So we've been working on this project since sometime last year. Runtime type system that Dmitry described has been deployed and in our code base, and users have been able to opt into writing those for about 6 months now, before the static checking was ever rolled out. The static type checker is currently in an internal beta internally. Engineers can opt in to see results from the static type checker and can run a command line tool to run it locally, see errors as they're developing. So it's not yet used by everyone, although we're hoping to get there, but right now we do have internal users and response has been pretty positive. To give you a bit of sense of the scale so far of adoption, engineers at Stripe, engineers other than the three of us, normal developers at Stripe, have authored a total of about 3,000 type signatures for methods so far over those couple of months of internal beta. They've opted in 150 or more files with that type checking annotation that Dmitry mentioned, in addition to the ones that we've opted in automatically based on analyzing the code base. So these are users who are playing with the type system, finding out that it's valuable and adding that signature saying, I want to type check this file, I want to make sure that it stays type checking because I'm getting value out of this system. In addition to those 3,000, though, there are another 240,000 signatures that we are able to infer or otherwise generate from our code base. For instance, by our support for Stripe's internal ORM, we can automatically extract types from our database objects, which gives us a lot more types to start type checking and start getting types and getting value even before we write more signatures. I want to talk a little bit about some bugs that we've found in existing code in the process of rolling out this tool. Stripe has a lot of tests. We have a great culture of testing. We have a great culture of code review. But of course, as you know, bugs do still sometimes slip through. And these are ones that the type checker was able to find that have been lying dormant for whoever knows how long. Fortunately, none of them were critical, but I think it's a really good lens that shows the kinds of bugs that we're able to find, the kinds of bugs in real code that this tool is able to find and eventually guarantee the absence of. All of the examples that I show you here are obviously simplified from our application to fit on the slide, but every one of them is directly inspired by a real bug that we found in our application while rolling out this tool. So we'll start with the simplest ones. Typos in error handling pathways have been a very common source of bugs that we found. Error handling pathways tend to get called less often. They often have less good test coverage. They don't happen as often in production. Errors in your error handling can go missed. Here's a simple one. The author wrote JSON parse error when the actual exception class is JSON parser error. And you can see that we flag the error. We know that that constant does not exist. And we helpfully suggest a related constant, which in this case happens to be correct. That's the one that you meant. We're able to search for nearby constants and give you helpful suggestions. In keeping with the spirit that Dmitry mentioned of really trying to make our error messages helpful to users. Slightly different case of an error in error handling. The developer here, perhaps they'd been writing too much Python recently. They tried to call argumenterror as a function instead of calling the constructor with .new. In Python, this code would work, but it doesn't in Ruby. And the type checker, once again, says method argumenterror does not exist. This is invalid. The nil check support, again, that Dmitry described, is also great for finding many real bugs. This is a simplified example of an API endpoint that updates a webhook endpoint in the Stripe API. The type checker knows that .load either returns a webhook endpoint or returns nil if that ID doesn't exist, and it knows that this update webhook function needs a webhook endpoint. It doesn't support nil. And so the tool was able to identify that, hey, there's a missing nil check here. This code doesn't work like you expected. If a user passes in garbage, we'll raise an exception. And if we fix it by writing the logical code that you might want to write, and that you would want to write anyways to fix this bug. You just check for nil and raise this user error, which is handled by our application error. The type checker handles this just fine. The flow sensitivity that Dimitri mentioned can detect this pattern and report no error. So we just had to fix the bug. There was no need to placate the type checker or write additional annotations. Another fun one that shows up at this typed strict level that Dimitri mentioned is accessing instance variables on self.static methods. In my experience working with engineers, this is a relatively common mistake to make by accident. You assign an instance variable in your constructor or in some normal method, and then you try to use the instance variable from a static method. In this case, they used the conditional send method because they expected it might be sometimes nil, and the end result in this code was just that request variable was always nil because it wasn't set in that scope. The type checker understands Ruby scoping, it understands instance variable declarations at typed strict, and was able to report that you're accessing an instance variable that is never assigned. There's no way this could ever work. And again, this came from real code in our application that we found in the process of deploying this tool. The last one, which is I think my favorite example here because of how surprising it was, because we never anticipated finding this bug, or this kind of bug, but it just fell out of the things that we built, was here someone had a minor misunderstanding of how Ruby's case statement works. They tried to check for whether this transaction object was either a stripe charge or a stripe refund using the Ruby logical OR operator. It sort of looks natural if you're reading through it, okay, when stripe charge or stripe refund. But what happens in Ruby is this is the logical OR operator, so Ruby says stripe charge or stripe refund. Stripe charge is truthy, and so this whole expression always evaluates to stripe : charge, and this case statement ends up only testing for stripe : charge. Apparently that was close enough to working, or they only ever tested this particular code path on charges because this bug was not caught by tests and went unnoticed in some utility script forever. We never wrote a test for this. You could easily write a RubyKaigi for this or other lint rule for this. It never occurred to us to write a check for it, but our unreachable code detection informed us you're using a logical OR, the left-hand side is always true, so this right-hand side is dead code. You must have meant something different. And so we were able to catch this bug kind of by accident by virtue of the tooling that we'd built, which was really cool and really fun when we discovered it. And like I said, we're in early beta. I wanted to give you a flavor of what users have said. I think the first one is really the most succinct one. Nice, beautiful errors, and damn, that was fast. Obviously, we're mostly getting people who are already opting into the tool, but reactions have been very positive internally. On the subject of speed, I want to talk a little bit about how fast our tool is, because one of the focuses for us has been on making a tool that gives our users input fast. So we can type check code at broad ballpark, these numbers obviously vary by code base, et cetera, ballpark 100,000 lines per second per CPU core. So that means we can do 1 million lines of code in 10 seconds. Just to give you some ballpark comparables, we type check at around 100,000 lines per second. Java compiles code at about 10,000 lines a second. And I benchmarked our particular RubyKaigi configuration. RubyKaigi varies depending on how many lint rules you have checked in your code base. But in our environment, it checks at about 1,000 lines a second. So we are by far the fastest tool that our users interact with in terms of giving them errors and feedback about the whole code base. And in particular, one of the other common tools that Stripe use is our test suite, which runs in continuous integration on pushes. Our test suite takes about 10 minutes to run our entire test suite, parallelized over tens of machines concurrently running tests, and that's been heavily optimized by a lot of engineers over the years. In comparison, we can type check our entire code base in seconds on a single machine. So again, we're obviously not performing the same checks, but we're getting users initial feedback about errors they might have made, getting them confidence in their code much faster. So how do we achieve that speed? Well, part of it is that our implementation is written in C++ as a standalone program that doesn't incorporate a Ruby VM or depend on a Ruby VM in any way. We have our own parser, which is a port of WhiteQuark's excellent Ruby parser that was written by GitHub in service of their type checking program. They haven't open sourced it yet, although they intend to, but they were gracious enough to lend it to us to power our parser, which saved us a lot of time. We do run an extensive test suite. We maintain unit tests in our codebase of programs that type check and don't type check for every feature that we build. And we also run our Ruby type checker against the entire Stripe codebase on every pull request to our repository. So we're running outside this ecosystem, but we make very carefully to constantly cross-check against it and give us confidence in our code and give us confidence that we haven't broken things, that we're maintaining compatibility. One trade-off of running outside a Ruby VM is that there's no sort of, we don't get support for various metaprogramming features for free in any way. We can't just load a VM and ask it what methods exist. To solve that, we have a couple of different solutions for different kinds of metaprogramming, different kinds of features. We have some native support. We recognize some patterns, such as attr, accessor, and other core Ruby idioms. And we also have some support for things like Stripe's ORM, and we can easily add support for other ORMs and systems like that. We additionally have a reflection-based separate program that loads our entire application into memory, uses Ruby's reflection APIs to figure out which methods exist, which classes exist, and output all of those methods and classes to disk in our type declaration syntax so that the type checker can then know about the complete set of methods that exist and the complete set of constants that exist in order to give better error messages. So that's been a little bit of an overview of what rolling this out into a really large existing code base has been like, and the reaction that we've gotten from our users, which is very positive so far, and some of the value and experiences we've been gotten. And with that, I want to hand the presentation back to Paul to close it up with a little bit of wrap-up.
Thank you, Nelson. First of all, I always like a photo of my presentation, so if everyone can wave excitedly. Yeah, thank you. Also wakes up the audience. Nobody noticed that small trick. Okay, in conclusion, can you use it today? You probably already have been. I've noticed a lot of people face down in their laptops. So please continue to load up sorbet.run. We will leave it up after the conference. Send us all your feedback, and please use it there. We will be open sourcing this. Again, unfortunately, we have limited resources, and we want to prove it out internally first, and then we will open source it out for the rest of the folks. We do not want to release vaporware. We don't want to even do a code toss. Throwing code over the wall, I did this once in my previous employer. It wasn't great. It's much better to support your code when you launch it, and we know that, and we would like to do that. So when we release it, we want to have a community-supported part. There will be a blog post, so subscribe to your blog if you have a RSS reader, if that still exists. Otherwise, hopefully a Hacker News post. And lastly, please contact us over email if you would like to be informed when it releases. Just send us a quick note. We'll add you to some sort of list. We want to hear from everybody today who's interested in this topic, but there are two categories of people that we are particularly interested in. Folks that are scaling Ruby at a large company or a large code base. We're very interested in your use cases. We're very interested in trying out the systems and seeing if they're useful for you. We also have been, as we said, on the developer productivity team for many years. So we have a lot of tooling that we have ourselves have built up over the time, and we'd like to compare and contrast how to scale Ruby at large companies. Please talk to us. Again, the bottom line of every one of my slides will be our email. The second set of folks we would really like to talk to are those that are also working on type checking. So please be in touch. We do want to collaborate. We do want to compare and contrast. And we would like to work together. No man is an island. Please come and talk to us if you are also interested in the space. Here are the takeaways from today, hopefully. Number one, we do have a type checker. It runs in your browser, you can see. It also runs elsewhere. It is fast and built thoughtfully. We do not want this to be haphazardly adding features. We're intending this for day-to-day use. Type signatures are meant to be useful and not burdensome. It is an optional type checker. You can put them on your core code where you want types, and you don't have to put them elsewhere. We will open source this project. Keep us to it. And please reach out. The email as follows, sorbet@stripe.com. And with that, I would love to thank the conference organizers for inviting us, a set of 3 people you've never heard of before, to come and talk to you about a type checker. Thank you, everybody, for taking your time and spending the last 40 minutes with us. And arigato gozaimasu.
We do have some time for Q&A, so if you have questions, please ask.
Come up to the microphone in the front if you do have a question. Unfortunately, you are not all mic'd. So please come up. There's 2 microphones and on the left.
Okay. So thank you for your presentation. But I have the question about SIG. Many Ruby programmers do duck typing. So for them, arguments of SIG should not be based on the class. Should based on the methods it responds. So how should we think about it?
We have a nominative type system. So we do not declare the shape of the methods, but instead the name of the class. It's a design principle.
Okay, thank you.
So it's part of the type system.
Yeah. We believe that the names matter. And thus, if you can't name what you're taking, you better think what you're actually implementing.
We do have interface support, so you can build out interfaces with modules.
So you have type annotations as well, and during Matt's talk, one of the questions was about static typing, and one of the things he mentioned is that he doesn't believe type annotations have a future in Ruby, because type inference will get there in like 10 to 20 years. What's your take on that? Do you see type inference getting there? Is this like trade-off you made or what?
We do believe that the annotations are useful. We think that executing documentation is important.
Yeah. Also, we need this now. We can't wait till 2040.
Nice to meet you. Did you have a follow-up? No?
Will it support to generate annotations from yard commands, for example?
We already have a translator that will spit out interface files from yard comments.
That's good. And again, what about duck typing? Because in the world, it's often when method will take some object that will respond to call or anything. So maybe it's better to add this. Thank you very much.
Thank you for the feedback.
Waiting for release.
Thank you. Thank you.
Thank you for the great talk. I have one question. I think one of the hardest parts of Ruby type system is existing assets, existing Ruby code that has no type annotations. You said you are not using Rails, but many people use Rails. So I think this is a problem. So how many libraries are you using? So that has no type annotation. Okay.
I think the question was how many libraries we're using.
Yeah.
Yeah. I don't have a number offhand. We do use a great many gems and libraries from the community. We do use a lot of community code. We have our main solution to that is the reflection-based signature generator that I mentioned. So we will load a gem and then walk the Ruby constant space and call .instance methods and use that to enumerate all of the methods that exist. So we don't know what types they return or what types they take, but we know which ones they are and we know how many arguments they take. So we get at least some checking, and we then write those out to files on disk so that engineers can go through and add and incrementally replace the no type known with some real type so that the checking gets better as we go. So we automatically generate partial support, which gives us some checking, tells us that they exist, and then engineers can annotate them as we go. And I think we're being told that we're at time, so I'm afraid that's the last question. Thank you all very much for listening.